Okay, so we are going to see TFIDF implementation. Okay, so this will be your you can use this file. So TFIDF, you know, term frequency, inverse document frequency. So we'll be using one package which is TFIDF, not package, you can call it function, TFIDF vectorizer. So it vectorize the sentence or paragraph in each word. This thing is available in scikit-learn. Learn, you know, right? Learn is an archive where you can get all the packages related to ML. So this code is little bit simplistic. Other codes we can write functions also for that. So first, what you have to do? So TFIDF vectorizer does, it converts a collection of raw documents to a matrix of TFIDF features, equivalent to the count vectorizer followed by TFIDF transformer. Means count vectorizer and TFIDF transformer. Count vectorizer and TFIDF transformer also together will give you TFIDF vectorizer. Otherwise, directly you can use this. So let's say this is our first document. First we have to okay. Then I am taking two documents here. In your exercise assessment 3 part A, you have to take multiple documents A, B, C, D that I mentioned in the question. You can find it. So just two documents I am taking, different sentences. Then you are going to create bag of words. You know bag of words, what is that? Bag of word model is a simplifying representation used in NLP and information retrieval. In this model, a text is represented as bag. Bag means multi-set of words and disregarding grammar and even word order, but keeping multiplicity. The bag of word model has also been used for computer vision. So bag of word, you know, without the positions of the word, a Boolean representation of document, Boolean representation of the words in a document. The bag of word model is commonly used in methods of document classification, where the occurrence of each word is used as a feature for training classification. So bag of word everywhere you have to use. So bag of word A and bag of word B. Next, you are going to find the unique words. What are the unique words? Unique words are when we ignore the case and punctuations. We are going to find the unique words. So to check the list of stop words, you can use the following. So to check the list of stop words, you know which are the stop words. For that you have to use this one, from analytica.corpus input stop words. Sir, okay, so it is done. Now this term frequency, you know what is term frequency? The number of times a word appears in a document divided by the total number of words in the document. Every document has its own term. Okay? So for that we have this compute term frequency, which is just that formula that we have kept here. Simple formula that we discussed in the class. Done. Term frequency. So term frequency is to document A and document B. Okay, next let us print this term frequency. So the term frequency, some terms are having no frequency at all, document A 0, and some are having values between 0 to 1. So similarly you can find document B also. Done. Now inverse document frequency, the log of the number of documents divided by the number of documents that contains the word W, whatever is word. Inverse document frequency determines the weight of rare words. This we already discussed in the class. That means the word apart from A and D, because A and D, those kind of words never makes any significance. Other words which make significance and carries meaning, those rare words only can be tapped using inverse document frequency. Okay. Inverse document frequency, you have a function here. You can also take this function while inverse document frequency is. Finally, TFIDF. Now IDFs also you have found, so just print it. So these are all inverse document frequency of the terms. Next, finally, you have to multiply term frequency and inverse document frequency. That is just a multiplication here happening. Okay, so print that TFIDF. Don't know whether it will be printed or not. No, it won't. You print it, students. Anyhow, you print this TFIDF final one. Okay, here it is there.